So, what does the analyst do in the steps of CRISP DM for data mining, which is a systematic process to go through data mining? We start with asking questions to understand the business's goals and priorities. This is part of the business understanding step. This helps you to define your project and how your project will advance the business's goals overall. You want to make sure that you're really clear on what questions you're going to be addressing and how those are going to relate to the goals of the business so that all of your actions can be tailored to that. Next is gathering the data and conducting quality checks for errors, inconsistencies, any missing values, running some preliminary statistics to get some initial insights from the data. And this is when you start to document your process and any issues that come up at this time. You also want to make sure that you're documenting any potential for bias in the data gathering or in the way that the data is being handled. So the next step is data preparation, where you clean data, handle the errors that you found, handle the inconsistencies, and any missing values, making sure that you document how those are resolved, how the integrity and quality issues are resolved. Then you'll also derive any new variables that you would need for analysis in this step. Next, you get into modeling, where you're sort of deciding the combination of logic and algorithms that you need to apply to the data set to design your model. And then you design the test plan for the model and construct your prototype. And this is where the testing starts to happen. You also want to make sure that you're documenting everything in this step as well, making sure you're documenting the reasoning behind, all the questions in the model and documenting the design of that model. So next is evaluation, where you're assessing whether the model meets the business goals that you defined in the first step, and making sure that you're getting feedback from the team to make sure that the model is a good fit or if there needs to be retesting. And this is also when you go through and reflect on the entire data mining process prior to this step and create arguments for or against the model that you created. You'll make visualizations for the model's results and create a presentation for stakeholders on whether or not the model should be implemented. Finally, there's the release of the model, and that the work doesn't end there. You will continuously monitor the model and document its output, review it, make sure that it's still a good fit. What does time series analysis involve? It involves assessing data for seasonality, autocorrelation, and whether the data is stationary or not. So you'll have to check to see whether the data is stationary by visualizing the data on in a graph, and then you can see that if it's stationary, it won't have any trends or any seasonality. You can also do this by checking descriptive statistics like means, medians, variance in certain time periods, and all of those things should be constant over time. You can check for autocorrelation by again, looking at the graph, and autocorrelation is when you can see repeated pattern in the data over time. And then seasonality can be seen as fluctuations that occur at regular intervals. And then, at that point, you can move on with your forecasting. The main principles of data ethics are privacy, transparency, accountability, and equality. In terms of privacy, all individuals should be in control of their own data, and as an organization, we have to obtain any consent before collecting or sharing private information. So that means making sure that we get consent from individuals when they sign up for something, download something, become a part of, interact with the organization in some way in which we are gathering their data. We can also, when we're analyzing data, make sure that it's masked, or that we're not using any identifying information that isn't necessary to the analysis. Individuals should also have a good idea of what information organizations are going to collect and share. And so as an organization, we need to provide clear and consistent messaging about how data will be used. So a good example of this is when you're signing up for cookies, or when you get to select what type of cookies you allow on websites, and what you can decide what the website is allowed to use and what it's not. Accountability. As organizations, it's our responsibility to keep individuals' private information safe, and if we're not keeping it safe, then we're accountable for that. So that means keeping up to date on any protection measures like firewalls, password rules, and having someone who's continually checking in on data protection and making sure that everything is in alignment there, so that we're avoiding data breaches. And lastly, equality. We have to be careful not to discriminate when handling and processing data. So this could look like masking or not using data that isn't relevant to the analysis, that could introduce bias into that analysis. So if years of education or spoken language aren't relevant to the analysis, then we can take them out of the data set that's being analyzed, just to decrease that risk of bias coming in. So if I was an analyst at a company and noticed that there was maybe some bias in a way a predictive model was measured. So measurement bias is usually when there's a problem with the machines or the humans that are collecting the data that are creating some sort of bias. So I would start with just sharing that I had noticed some discrepancies or something coming up in the model, and share that with my manager and ask them if they had noticed the same thing. I'd ask if there are, maybe there are steps that are already being taken to address that bias. And if there aren't already steps being taken, I could offer suggestions, like making sure that there were multiple devices being used, or that there were multiple testers for the model. Might offer to help improve testing procedures if they aren't clear, or if they hadn't been explained to evaluators. Or I might ask, okay, how are we choosing evaluators for the model? how are they being trained? Are they, what's their experience like? And make suggestions there. Can also ask what the review and evaluation process is like for the project to make sure that it's being kind of reviewed and updated continuously. And really just kind of come at the entire thing from a place of curiosity and not of blame, but just, I wondered if you had noticed this too, and offering to help address the things that I was noticing. So the final question is the difference between regression and classification. So models in predictive analysis. Regression analysis is usually when you have numerical data and you want to explore the relationship between two quantitative variables, and classification models are used when you have categorical data. So there are two main regression types. There's linear regression and logistic regression. And linear regression uses two quantitative variables, and while logistic regression, the dependent variable is categorical. So a linear regression might investigate how the length of stay, like days, number of days, impacts pounds of weight regain. Both of those are numerical, and a logistic regression could investigate how pounds of weight regain impacts whether or not somebody is readmitted. So that's, one is numerical, the pounds of weight regain, and the outcome variable or the dependent variable is categorical. Somebody is readmitted or they're not readmitted. And then classification models predict whether an observation will end up in one category or another. So an example, you could use a random forest classification model to ask a series of questions and determine whether someone is likely to be readmitted to a treatment center or not readmitted to a treatment center. So every question along those decision trees that make up the whole forest is categorical and will finally lead you to a kind of yes or no, or even along a spectrum of very likely to be readmitted or unlikely to be readmitted. Still categorical, but a little bit more nuanced.